1 times cos 2 alpha is the distance from here to here. So 1 minus the distance from here to here is h. 1 minus cos 2 alpha. Okay. That's the height of the shaded rectangle. Or rectangle. Yes, that's a rectangle. The shaded figure. How's that? How's shaded figure? Height of the shaded figure. What's the base of the shaded figure? So we can write this. The area, the incremental area, that's the area of the shaded figure triangle, is the base times the height. Right? Yeah. Now, okay. Now we got to massage the expression here a little bit.
I would not substitute cosine.
Yeah, we'll do that.
Yeah.
What's the half angle formula? Cos 2 alpha, 1 minus cos 2 alpha over 2 is equal to sine squared alpha.
Yes.
Okay. So 1 minus cos 2 alpha is 2 sine squared alpha over 2. So we have now, at this point, after making that substitution, good call there. The incremental area is delta x times sine squared alpha. Okay. We can also write this. Then we can divide top and bottom by sine squared. When I do that, I get cotangent squared. Yeah, we're going basically in the right direction. I'm not going to divide by side. I like that. That's what it goes.
On the plus side.
Yeah.
Tangent squared. Over.
Right. Well, we just can't let x be tan alpha. X is tan alpha, right? Here it is. did that with some measure of foresight. Don't be hating.
Oh, okay, I see where we're going.
All right. So if we integrate this function, if you graph it, when x is 0, it's 0, when x is 1, it's a half. And it kind of goes like this. So we would like to go from 0 to 1 with this function. Yeah. Now here's what Leibniz did with great foresight, insight, and foresight. Instead of trying to integrate x squared over 1 plus x squared, sorry, it is this one. I'm going to write 1 over 1 plus x squared is 1 minus x squared plus x to the 4th minus x to the 6th. You guys are stupid. Remember these. In fact, I'm going to make this w because we're letting this one here. This one is just 1 plus w squared plus all the positive powers, and this one is the same thing except they alternate, so minus, plus, right? So letting w be x squared, I generate this infinite series. This is only going to be convergent if x is less than 1. That's good because x only goes from 0 to 1. We're all right. There's nothing else there. What do you want?
I didn't know it was top of the line. I didn't know it was going to be on the internet. We take notes.
All right. So now, delta A is going to be x squared over 1 plus x squared, but that is this. Multiplying that out. Yes, sir. It's uniformly convergent. So that is kosher, and when we integrate this, I've conveniently dropped the integration. When we integrate this term by term, we get x cubed over 3 minus x to the 5th over 5, x to the 7th over 7, minus x to the 9th over 9, blah, blah, blah. Right?
From 0 to 1.
From 0 to 1.
1/3 minus 1/5.
Right. So we get a third minus the 5th plus the 7th minus the 9th plus the 11th. All right. So that is the hard way to calculate the area of the blue shape there. What's the easy way? Elementary geometry.
We define the area square, subtract the area of the section.
1 minus, well, pi r squared is pi, right? It's a quarter circle, so it's pi over 4. So apparently, the other way of doing this is to write that.
Right.
Transpose the pi over 4 and the series terms, and what do you get? There is Leibniz's famous series for the arcane. Which converges very slowly. This is not the way to calculate pi. It's notorious for converging very slowly. Remember, I had a friend who, I think he was in junior high school, he saw this somewhere and decided, my God, I'm going to calculate umpteen digits of pi. And this is back before calculating. My God, it's a mess. You know, pi is 4 times that expression. And it just converges very slowly. Impractical for calculation.